Hi everyone. Our paper is titled How Not to Overpackage AI for Sustainability in HelloFresh Service Supply Chain. HelloFresh is the largest global provider of meal kit subscription services. How it works is that every week, customers choose a number of recipes from the menu for that week, and HelloFresh sends the corresponding ingredients, condiments, and recipe sheets to the customer store. For each box of meal kits, liners and freezer packs are needed for temperature control. As you can see in this picture, this box has white foam liner materials and some freezer packs at the bottom. These packaging decisions should be customized for each box because each box has different contents, sizes, destinations, and transit conditions. We formalize this problem as the contextual packaging problem, which has wide applications in delivery services for goods such as vaccines and fresh flowers. Packaging waste is a common challenge faced by meal kit services. This Forbes article from 2017 states that Blue Apron generates an estimated 192,000 tons of freezer pack waste from their deliveries in 2016 to 2017. The article says this is the weight of nearly 100,000 cars or 2 million adult men. People wonder if these services are overpackaging. And if you think these numbers are jarring, they have grown even larger due to the drastic growth of the market. The numbers in the article are for 2016 to 2017, when Blue Apron was still the industry leader. As you can see in this chart, HelloFresh has surpassed Blue Apron by far in size since then. Our paper designs an online learning contextual Band-Aid algorithm that makes the packaging decision intelligently for us, to minimize overpackaging and the environmental impact, and to build a more sustainable supply chain. Under the contextual Band-Aid framework, in each round T, we have a box we need to package. We receive the contextual information that may affect the outcome distribution for each packaging decision. Here are two examples of contexts. Each row is the context for one box. Given the context, our algorithm chooses an action from the packaging combinations. Here are some example actions to choose from. So there are these liner grades and freezer pack weights. In each round, the penalty function consists of three terms. The first term is the environmental footprint, the second term is the material cost, and the third term is the failure penalty, which happens if the packaging was insufficient and the box was too warm. The first two terms are known a priori and deterministic, given the context and our action. And the last term is random and realized afterwards. The trade-off is between overpackaging versus insufficient packaging. Here are the main results. Our algorithm, contextual one-sided arm elimination, tackles the contextual packaging problem with an optimal square root T regret guarantee, which means that we receive theoretically minimal penalty over the horizon. We leverage the large amount of offline historical data to accelerate online real-time learning, and our algorithm quickly pinpoints possible overpackaging in the existing guidelines. We provide a number of structural theoretical results in the paper. In addition to theoretical results, we also work on the ground with HelloFresh. In particular, we work with a large historical delivery dataset of over 400 million records joined with other associated datasets. A big challenge in using historical data is confounding because past actions were heavily correlated with past contexts. Whenever the temperature was a little higher, a lot more packaging materials were used. So if you run a simple linear regression on the data, you will find that higher temperature is associated with lower probability of failure. We resolved the confounding issue and the sparse signal issue simultaneously by devising a method called data injections described in the paper. We conduct numerical experiments, and our algorithm was able to identify scenarios where the current guidelines might be suboptimal and overpackaging. Here are some example scenarios. In Figure 6, you can see that for large-sized boxes with destination maximum temperature being 30 degrees Fahrenheit to 36 degrees Fahrenheit and one-day transit time, the current guideline seems to be overpackaging. Prior to this project, the thermal engineering team conducts physical chamber experiments on different configurations of boxes one at a time. Our method learns the optimal packaging strategies much more rapidly and can identify possible overpackaging points in the current guidelines, reducing material waste, saving time and resources. Thank you so much for your time and attention.